Hello, Dan. So, what is your role in the EreTech project?
Yeah, hello. My name is Daan. I'm working as project manager for HYGEAR. HYGEAR is one of the industrial partners within the EreTech consortium, and our role within the project is to produce, develop, manufacture a fully containerized solution for producing green hydrogen. We are going to use the SciPox development for a 250 kilowatt electrified steam methane reformer, producing in the end 400 kilograms per day of fuel cell grade hydrogen using biogas as a feedstock for the reformer.
I was wondering, Gianluca Paoletto has explained the pilot 1. You are preparing the pilot 2. What is the difference between pilot 1 and pilot 2?
Yeah, pilot 1 is also 40 feet container developed by SciPox with the sole purpose to test the performance of the electrified reactor that is developed by them. We are going in pilot 2 one step further. We are going to add an extra step to clean up and purify the hydrogen to reach the fuel cell grade hydrogen. We are going to do that in two different steps. First, the reformate gas, what is coming out of the reactor, is using a water gas shift reactor where we are converting the unwanted CO, which is produced in the reformer, to more hydrogen by the water gas shift reactor. And the second step, we are going to purify the hydrogen using HYGEAR's development pressure swing absorption technology. And this way we are able to produce 99.999% of pure hydrogen, also called 5.0 quality hydrogen.
I have just a personal curiosity. Why is electrification so important?
That's a good question. I can elaborate on that, but first it's very important to understand that steam methane reforming is a highly endothermic reaction where methane is reacting with water at a temperature of 900 degrees to produce hydrogen. Nowadays, conventional steam methane reforming is fully relying on burning fossil fuels to provide this heat for the reaction. And of course, as a consequence, this contributes quite significantly to the CO2 emissions. In contrast, with an electrified reformer, as the name suggests, we are using electricity to provide this heat. As a consequence, you are eliminating all the emissions, CO2 emissions related to combustion of fossil fuels. Another really important advantage is that it's much more energy efficient, but also resulting in much smaller reactors compared to conventional steam methane reformers. And last but not least, it's reducing significantly the footprint of CO2 emissions for hydrogen production. So that's a really important step forward in the decarbonization of hydrogen production, especially if you realize that nowadays more than 90% of all the hydrogen produced is by the conventional steam methane reforming. So electrification really has to be seen as to bridge the gap towards a fully green hydrogen being widely available by water electrolyzers, which will take many years. So this is a really important step in between to use electrification.
Fantastic. So the very last question is, when do you think that the pilot 2 is going to be ready then?
Yeah, we are currently in the assembly phase of the project. 2 weeks ago we have received a fully customized 40 feet container at our factory in the Netherlands. So it was really a happy moment for the HYGEAR team to start with the production. We aim to have it finished in June, fully certified and ready for shipment to the biogas site in the south of Germany, where it will be tested for about 4,000 hours until the end of the year. So exciting period ahead for HYGEAR and the EreTech project. Yeah.
Dan, thank you very much for your fantastic explanation.
You're welcome. It's a pleasure.